Hello everyone. In this video we have to see about the case study on X-ray instrumentation and its applications. So X-ray after invention of the X-ray it will be used for finding the atomic positions of the various crystalline materials. So mainly there is a three experimental methods. We have in this video we have a case study about the how much is important, how what are the material we have used for identifying the atomic orientation in the crystal. Mainly we have used the Lawey method. Next one is the Vishnell method, that is the precision method. So it is nothing but we can produce the different type of atomic parameters according to the material. So it is the first one is the Lawey method, is nothing but it is a front scattering or back scattering. That is the you can see the first row of images, that is called the first column of images, the Lawey method. It will the crystal exposed by the X-ray that after diffracted image captured on the photographic plate, it will produce different orientation of the crystals. We can see that column, the lower bottom. You can see the black and dot point is indicated nothing but the projection of the atomic lattices on the diffracted plates. That is called as identified by the Lawey. Next one is the Wiesner-Heisenberg, that is the rotation method. The crystal will be rotated. The photographic plate also rotated, and the center of the crystal will be placed. So it will be get a roller type of that photographic image. That is the dot points of the called as a lattice diffracted image. It will be calculated by the find out by the Wiesner. That is the instrumentation that will be used for that production of the photograph. Main is nothing but Wiesner. It is nothing but the photographic plate rotated on the cylinder, and the X-ray will be the crystal will be placed on the center of the cylinder. It is nothing but center of the rolled photographic film. The crystal will be diffracted along the three-dimensional 360-degree. So we can guess the photographic plate according to that. Next one is a precision method. That is the we can rotate also the photographic plate according to the rotation above the crystals. We can get the images like dotted planes on different orientation of. We can rotate both rotated as crystals and photographic plate according to the precision method. We can find that all the possible diffracted images from the crystals. So these are the main different method we have used for that and identify the crystalline materials. So you can see that that is the one of the now recent years we have developed different instrumentations, that is called as a 4 axis of the crystal rotation. That will be the crystal orientation. During the X-ray diffraction, the crystal and detector will be moved along according to the orientation. It will be fully automated. You can see that 4-dimensional angle. That is x, omega, theta, and pi. It will be rotated along the one axis. The crystal will rotate also in the 8 angle. The detector will move along the another angle, and it will rotate it about the upward direction will be called as another rotation. So we can indicate the left image indicate the rotation about sigma orientation, and diffracted 2 theta is nothing but we can get detector images, and rotated about the crystal is called as pi, and chi about the rotation of the circular motion of the holded holder. So it is called the four different angles that will be rotated. So these are the latest instrumentation of the X-ray. You can see that real instrumentation about that rotation about the holder that is called as a goniometer will be rotated on through the 4 different axes. So this is the main instrumentation nowadays we have. These are the crystal we are mounting. So it is we need a very minimum size of the crystal, about 0.1 micrometer, 1 micrometer to 2 micrometer will be hold on that the small fiber tip. That is the crystal. You can see that the images indicate that how much is very small. It will be exposed to the crystal. Will be gives the complete structure, atomic structure of the atom. So it will be very minimum size. So it is a very out of skill work to mount a crystal on a fiber. It is having the time indications. So we can mount the crystal at a fiber. We can expose to the crystals is a very minimum. So it will be used for fab study the crystalline atomic structure of the material. It will be very minimum size. So these are the mathematical basics will be based on that different softwares we have to use for the finding the crystalline structure will be used for the identity, that is the Fourier synthesis method we have used for, and direct and Patterson method we have used for the fabrication of crystals. This is the main programs we have used for the crystal structure, that is a molecular modeling out of Kaplan pattern will be used. Finding the crystal structure we have used Select and CSIR-NET program, and refinement program is called as Select. So many softwares will be used for the fabric find out the electron density. This is the structure model, that is the shows the electron density of mapping. After getting that data from the data, we can manipulate it through the softwares. We can get the unit cell images and atomic positions, and similarly right side we can see that that is the red green color indicate the electron density mapping of atoms in the crystal structures. So in this video we have stopped that, and it will be used for various application to the materials. So that is the main application is the nothing but crystalline material and non-crystalline material. So if it is a finding these type of material to identify that silicon and non-silicon. Best example is the silicon oxide. The pure silicon oxide is nothing but crystalline materials. Non-silicon is called amorphous. It will be used for various applications. The orientation of the crystalline material will be identified. The X-rays will be used for various types of applications. Example, diamond plate, and this is called as ignots. So ignots will be mainly used for the fabrication of the integrated electron chips. Will be used for the fabrication of the semiconductor industry. So that is will be very different application according to the crystal. So without crystalline material study of the structure, we cannot use it for the device fabrication. So in this video we can stop here. Next video we can start with another important topic. Thank you.